Alright, today we're going to be continuing Chapter 5, Section 1, dealing with graphing quadratic functions. Alright? I know you're probably wondering what we're doing right now because I've been making YouTube videos all year long with all of the concepts. So now you can go back and look at it. It's been a while since you've done it. Alright? So here we go. Right now, this is problem number 3. Like I said, we're in Chapter 5, Section 1. Before we move on, we're going to do a little experiment here. Alright? I want you guys to notice something. We have, wait a second, pointer tool. There we go. All right. You guys notice right here, this is the a value. Which term is the a value? What is ax squared? Which term is ax squared? The quadratic term. Very good. So notice right here, the ax squared makes this a parabola. If the number gets bigger, what happens to the width? The bigger the number gets.
The bigger the form.
All right? So the greater the absolute value of that number, the more narrow it is. Okay? So I'm going to try to get it back to 0 if I can. I don't know if I can. Well, looks like I'm not able to. That makes me sad too. All right. So what's the bx part? Which term is the bx? That's the linear term. All right? Watch what happens when I change that value. Can you guys carefully see that little thin line right there? See how that's a line? And what does that do to the graph? It kind of moves it. I'll make it a little bit easier so you can see. Check this out. See how it kind of moves the graph? And what's this graph tangent to? Tangent means touches. It touches that particular line. You know what? Not a right line. All right? Okay, let's do a little bit easier question. What does the c value do? That's the y-intercept. It just moves it up and down. So right now you can easily see that the y-intercept, by the way, Justice, you may not know this, but when you're crippling papers in the background, that's all you can hear. Crippling. So this goes up and down. This is your linear term. Linear term. This is your quadratic term right here. Oh, there we go. Come on. There's your quadratic term, and the c value is your constant. All right. So now we look at number 3. By the way, Dylan, just so you know, probably hear the crunching in the background too.
You just get on that roll into it.
Oh, it's still recording. Yes. Ax squared is your quadratic term. Bx is your linear term, and c is your constant. So I'll write that down right here in case somebody who's really bored is watching this and hasn't muted me already. All right? This right here is your quadratic term. This one right here is your linear term. And this right here is the constant that comes at the very end. And the cool thing about this is what's your constant always going to be at the end? It's always going to be your y-intercept. Very good. So right now, before I even do anything, JC, I'm just going to say my y-intercept is at a 0 what? Oh, 0, 1. All right? By the way, shout out to Shelby if she's watching. All right? Did you miss her? She said she would still watch, and I told her I'd give her a shout out in the next video. Shout out to Shelby. All right? So, right here, can anybody tell me my a value, my b value, and we already know our c value is 1. What's my a value? 2. What's my b value? No, take your blame.
-2.
-2 is correct. Okay. All right, so we have a is 2, b is -2, and c is 1. The next thing we're going to do, everybody, in your journal, I want you guys to write. We're going to find the axis of symmetry without using the graphing calculator. We are just going to use a special formula that gives us the axis of symmetry. X is equal to a special formula called -b over 2 times x. And what was our b value? Our b value was a -2. So I have to put a negative and open up a parentheses. I'm going to put another negative there. And what is our A value? Our A value is a positive 2. So we get a negative times a negative, which gets us a positive 2 over a 4. Uh-oh. What's our axis of symmetry? Our axis of symmetry is actually a half. Interesting. So sometimes the axis of symmetry is not going to be an integer. It's not going to be at a 1, a 2, a 3, or a negative 4. It's going to be at a fraction. Sometimes it can be at a fraction. So right here, what I'd like you guys to do on your assignment right now, since we found the axis of symmetry, here's what I want you to do. I want you to carefully draw in your axis of symmetry, and you don't have to use a dotted line. I'm going to, just so you know, that's the axis of symmetry, at a half. So on your paper right now, draw in your axis of symmetry at x equals a half. So right now we know that y-intercept is going to be at 0, 1. The next part we found, we know what the formula for the axis of symmetry is. So, what's that? It's at x equals a half, and I will answer your question. Let me pause, and I'll answer it. Okay, now that we have our axis of symmetry right here at x equals 1/2, we have our y-intercept that's going to be at 0, 1, and we now need to find our vertex. So let's go back to our original quadratic function, which was 2x squared minus 2x plus 1. What I'd like you to do is I would like you to take this half, and I would like you to plug it in for x right here, and I want you to plug it in for x right here, because the vertex, we already know our x value. The x value for our vertex is the half that we just found. What we need to find, everybody, is we need to find f of x. By the way, what does f of x represent? It represents our y value. Okay? So remember this right here, this represents your y. So we're going to plug in, what is our y value, which means what is f of x? All right, so basically, another way of saying it, what is f of a half? What is the function going to be? What is the y value going to be when you plug in a half? So you're going to plug in a half. Just like that. By the way, you guys can do it in the calculator. I'm just going to do it by hand. 2 times a half squared, a half and a half make a quarter. Negative 2 times a half is a negative 1. If I multiply 2 times a quarter, I get a half. If I take negative 1 and I add a 1, those cancel out, so basically I'm left with a half. But what I'm saying is this. If you type this into the graphing calculator, eventually all you're going to get, and the calculator will probably say 0.5 in the calculator. Well, then you did something incorrect. Oh, I see what you did. Right now, I told you to put a half in. You did a negative and a negative. There's only one negative here. You put 2 negatives in your calculator.
Oh.
Okay. So, by the way, your vertex, everybody, is going to be at a half, half. That's the third answer that you need on your paper. A half and a half. Now, where do you plot that? Here we go. Ready? You're going to plot it right here. That point right there is a half, half.
Negative b over 2a.
Negative b over 2a.
When it's negative 2 on that one.
That's why it makes it a positive.
It makes it a positive, so these 2.
You got it? All right. So, right now I'm going to turn my calculator on. I'm going to hit y equals. You guys have probably already done this. We put 2x squared minus 2x plus 1. All right, and I'm going to hit the graph button. Now, when you guys look at this graph right here, let me show you something in the calculator. There's a feature in the graphing calculator that makes things a lot nicer. Watch this. Ready? Hit zoom and go to number 4. Now, if you have a colored TI-84CE, like I have up here, you can also do one more thing. You can format. So in second, format, and I'm actually going to put the grid lines on.
So after I press second, then
And that kind of gives you a better idea of what the parabola is going to look like. Okay? Now, if we go to our table, everybody, so far you guys should be able to at least look at your table. Go second graph. I want you guys to notice something in the table that's not there. You guys see how these line up? We have 5s and we have 13s and 25s that are on mirror images of each other. Okay, but what don't we have in the graphing calculator? We don't have what right between the two ones? What coordinate fits right there perfectly between a 0 and a 1? A half. And what did we figure out the x-axis symmetry to be? X equals a half. And what was our y coordinate? That one right here? Right here, this was a half, and over here was a half. So what I want you guys to do on your table, I want you guys to start at 3, then go to 2, then go to 1, then go to 0, and then I want you to write in a half, and then go to 1, and then go to 2, then go to 3, then go to 4. When I say I want you to write a half and a half right here, hopefully you guys understand, the vertex is right there between the 0 and the 1. Thank you, Andrew. That should be a -3, -2, -1. Good job. All right? So yes, we're counting down. I just forgot to put the negatives there. So we'll go -3, -2, -1, 0, 1, 2, 3, 4. All right, Andrew, why don't you give me the y coordinate for -3? So we can't graph that one. So that one, we're still going to put it there, but we can't graph it. The next one, 15, 13. What's -1 go? 5. And then we have 1. Now, right here, notice these numbers are going to be mirror images right over here. So we have a 1, you should have a 5, a 13, and a 25. The only numbers you're actually going to be able to plot on this particular graph are these right here. I wanted you guys to list, other numbers, but right now these are the only ones that we're actually going to use, okay, for this graph. So we're going to go to -1 and go up 5. 1, 2, 3, 4, 5. We're going to go to 0, 1, which is right here. We're going to go to 1, 1, which is right here. And finally, we're going to go to 2, 5, which is right here. Now, if you want to try to do an accurate drawing of this particular parabola, I want you guys to understand it's going really, really, really steep, because where are we going to be at -2? We're going to be way up here at a 13. And how high does this get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 13 would be way up here. So we're going to come down from there, go through that point, and then through your vertex. And remember what we talked about, the A value? The greater the absolute value of this number, which is a 2, what's going to happen to our graph? It's going to become pretty narrow. So this graph is probably the most narrow that you've drawn so far. Oh, the y-intercept right here, look. See a number right there? That's your y-intercept. C is your y-intercept every single time. Okay? So, in review, what we did first, the very first thing I wanted you guys to do in review is I want you to label your A, your B, and your C. First thing, label A, B, and C. Next thing I want you to do is I want you to establish what your y-intercept is. Next thing, I want you to use the formula x equals -b over 2a, which finds you your axis of symmetry. Once you have that, then I need you to plug it in to find the y coordinate of your vertex. And lastly, then I want you to type it in the calculator and you can find the rest of your points. Okay? And then there's your graph. There's your final graph. Okay? So start with your ABC, find the y-intercept, find your axis of symmetry, then find your vertex.